welcome back. So this is the fourth video for week 3, and this is what we call the max-min model. Now this is from chapter 5. This is where your textbook author is talking about, constructing a conservative portfolio. So this all starts on page 231, and your author gives you this data. And I've taken the data and I have transposed it so that it looks more familiar to you guys when you put it into Excel. So here are all the year 1 returns for our 6 securities. And recall that this is a foreign stock, international bond, long-term growth, long-term growth, long-term value, short-term growth, short-term value. All right, now I'm going to get back to this M minimum in just a minute. So we're given all these returns, and the idea here is we want to maximize the minimum return, okay? Hence the reason we call it the max-min model. So how do we go about doing this? Well, I think, hopefully you would agree that reading the textbook, I think conceptually it was easy to understand the model and the constraints. What you may find difficult is how do I put this into Excel, and that's why I wanted to go through this with you. So let's get started. So I've got my choice variables here, and these choice variables are the percent of funds that you're going to invest in these various securities, okay? And then here I've got the returns for each of the 5 years. And then here I have my constraint, right? So, if I invest X percent in these returns, if I invest X percent in these securities and the year 1 returns are the returns that we get, then we would have earned 21.7%. However, right, had the year 5 returns come up, then we would have only earned 6.44%, okay? All right, well, how does Excel find the maximum of the minimum return? Well, it does this in a very kind of convoluted way. So the author points out that the minimum actually needs to be a choice variable. So that's why you see me putting it up here with my other choice variables, okay? So, I've already solved this problem, and this is actually the answer. So for our purposes, I'll just go back, put in some zeros, okay? So this minimum is going to be a choice variable. Well, then the objective function, now bear with me, the objective function then is going to equal that choice variable. Now, it's okay in Solver if your objective function is equal to a choice variable. That's fine. More importantly, just so you know, the reason I can't make this a 0, this objective function, is because in Excel, your objective function has to be a function. So like normally we use the sum product function. Well, in this case, I'm just referencing the minimum minimum return, right? Well, this works in Excel because what Excel is doing, since this is a choice variable, Excel is putting in numbers there. That didn't work out well, but you got, I would have put that in the right cell, right? So that's why this works. So this objective function is changing every time Excel does something. Every time Excel finds a new percent or changes the minimum value, our objective function is going to change, and that's what we needed to do. So there's my objective function, and then you'll see here, right, and your author points this out, the constraints all have to be greater than or minimum to that minimum value, right? So I just referenced them, all these, I just referenced them to the objective function. Now, if you'd like, you could have just referenced them to the minimum value itself. It's not going to matter. I'll just change that now so you can see that. Okay. All right, and then finally I have my last, so these are my 5 constraints, right? The returns for each of these, and I should call these scenarios, right? The way the book, the way I read it was, here are some historical returns, and, we think these returns are potentially valid for the coming year, right? And so we want to determine what is going to be the minimum return. Actually, we want to know what's going to be the maximum of the minimum returns in the coming year, okay? So, at any rate, the last constraint I need is, the sum of these choice variables has to equal 1. Now, notice I'm excluding the minimum, right? So here I just take the sum of the percentages that I'm going to invest in each security, and I say, look, that's got to equal 1, okay? So, how is this all possible? I mean, seriously, what is Excel doing? Why does this work? Well, what Excel, for example, is doing is I'm just going to use a minimum return. Well, I'll use the minimum return of, say, 2%. Okay? So Excel puts that in there. And then, of course, I've got that link. So now I've got it, as part of my constraints. Then what Excel does, in a sense, is say, well, what if I equally weight all these investments? So 1 divided by 6. So then Excel says, okay, if I do that, well, then I'm going to get a minimum return. And obviously, in this case, I can't do that because I've got this negative. This negative is not greater than 2, but Excel has not found a solution yet. But what Excel does, it says, okay, well, the minimum return for this particular setup is the negative 5.81. All right. Well, then it says, well, maybe I should reallocate these percentages. So, okay, so I'll put in a 0.2, 0.2, 0.2, 0.2, 0.2, 0. And it says, ooh, here's my minimum here, negative 10.4. All right. So Excel keeps on going. And it obviously is doing this in a lightning quick way. So I'll just go to 0, 0.2. Ooh, now I got a minimum of a negative 2.5, 2.6, right? Negative 2.6. Okay, well, here's what I'm trying to get at. Excel keeps on doing this and doing it and doing it, and it does it very quickly, right? Excel is basically keeping a list of all the minimum returns that it found when it changed all of our choice variables, okay? And then what Excel does is it says, well, what was the maximum of all of these minimum returns, okay? And that is what it's going to put in here, right? Why? Because I am maximizing the objective function, but of course the objective function is equal to the minimum variable, right? So Excel just keeps changing the percentages I'm going to invest, and then, it sets this minimum amount, and then it finds out, well, which one is truly minimum. I'm sorry, which one is truly a maximum. Of all those minimum values, which one is truly a maximum? Okay, so that is the basic setup for this problem. Now let me get rid of some of this stuff. So again, I have 7 choice variables. I went too far, right? My objective function just equals my minimum, right? These are all the same, but notice that these are equal to my minimum. And then here is my sum of all my percentages invested has to equal 1. Okay, so now let's solve this guy. Okay, so solver. So what do we have to do? Okay, so first of all, right, here's my objective function. I'm going to maximize that. Now notice this. By changing B2 to to H2, right? Because these are all of my choice variables. And something has gone horribly wrong here, so I'm going to delete that. All right. And then I have my subject to constraints. I have these constraints, right? H5 to H9 are greater than or equal to J5 to J9. And then I have to put in this constraint, right? This number equals this number. And I hit add. And then actually I have one more constraint to put in. Now normally we have this non-negativity constraint, right? That all of our choice variables have to be greater than or equal to 0. But in this particular problem, that is not true, right? Because as I've shown you, right, the 3 examples that I've shown you, the maximum of the minimum returns was actually a negative number, right? We can't force that minimum to be greater than or equal to 0, right? Some of these returns are negative, right? Negative, 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 blah, 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 negative, negative, right? So it would be inappropriate for us to mandate that the minimum be greater than or equal to 0. So what I have to do is, in a sense, manually do my non-negativity constraints. So to do that, you actually highlight these choice variables, and then you set them greater than or equal to 0, okay? And then you uncheck that box, okay? Now the minimum variable is allowed to take on any number between negative infinity and positive infinity. All right, and then you're done. Simply hit solve, and voila. Excel has found, right, that the maximum of the minimum returns is 6.44516. It gets there by allocating 55% of the funds to international bonds, 13% of the funds to long-term growth, and 31% to short-term value stocks, right? Or funds, whatever they were, funds. And there you go. So this allocation of money leads to the maximum of the minimum return, okay? So in other words, the minimum return for these 5 scenarios, right, cannot get any higher, right? Because this is the maximum that the minimum can take for these 5 scenarios. All right. So I hope you understood that. I do apologize. I know, like this particular problem, it can be hard to wrap your mind around because you're doing the max of the min and what's the max of the min and then just how do you set it up, right, properly is another big issue. So at any rate, that's how we do the max min problem in Excel. And obviously this is directly related to financial planning. All right, well there you go. There is video 4. Up next is video 5.